The expander body pile technology. Applications in sedimentary, sandy soils. The expander body pile, initially developed in Sweden by Bo Skogberg, has been introduced and further developed successfully, applied on a large number of piling projects in the Santa Cruz region of Bolivia. In many populated regions of South America, soil deposits consist often of loose to medium-dense sands and silts, often with high groundwater table. This presentation describes the main features of the expander body pile, and in particular its practical application on projects, including design aspects and installation monitoring. The traditional soil investigation method is the standard penetration test, SPTN, values increasing typically from very low values close to the ground surface, to average values of 15 to 30 at larger depth. However, the quality of SPT results is variable, as such soils are easily disturbed. The design of piles is usually based on the standard penetration test, which is performed with little or no quality control. Conventional deep foundation method. In Bolivia, the most common pile foundation method during the past 30 years has been the auger piles, drilled and concreted under support of bentonite slurry. As a result of the use of cheap and crude boring tools, the quality of pile installation is often low. The most important problem is the lack of quality control and monitoring of the installation process, which results in high factors of safety and poor project economy. The expander body pile system. The EB consists of a folded steel tube with a round cross-section. By injection of grout, the EB can be inflated, thereby creating a watertight steel cylinder of high strength. The EB diameter prior to expansion is approximately 120 mm but increases during the inflation process to between 400 to 800 mm, depending on the EB size. After expansion, the diameter of the EB has increased by about 300% to 700%, depending on EB model. Installation methods. The EB pile is very effective when installed in loose to medium-dense sandy and silty soils. As the EB cross-section before expansion is small, installation of EB piles can be by conventional drilling, driving, jacking, vibration methods, or by placement in a pre-formed hole. The grouting process of the liquidite EB takes place under controlled conditions without leakage. Thus, it is possible to measure the gradual increase in EB volume and the required grout pressure. Due to the controlled expansion process, horizontal soil stress, soil strength and stiffness of the soil around the EB can be improved significantly. An important advantage of the EB monitoring system is that the actual condition of each EB pile toe can be monitored and evaluated. The Swedish Commission on Pile Research has published guidelines for the design, execution and control of the EB pile. The EB pile is included in Eurocode N 12699 displacement piles. Post-grouting. A special feature of the most recently developed EB system is the possibility to post-grout the soil below the EB. During the expansion, the EB diameter increases, but at the same time, its length is reduced. This shortening of the EB can result in reduced soil stress below the EB. This injection is performed 24 hours after the injection of the EB. The risk of soil decompression below the pile toe, due to the shortening of the EB, is in most cases not significant. Installation monitoring and quality control. For each model of expander body, exists a calibration curve. As the EB functions similarly to a pressure meter, the expansion process provides information regarding the soil conditions during EB inflation. From the pressure volume curve, it is possible to establish the geotechnical conditions of the soil. Also, the volume of the EB and thus the pile toe area can be determined for each pile. All relevant parameters, such as flow rate, pressure, and volume of grout, are recorded by a computer-controlled data acquisition system. The applied grouting pressure reflects the soil resistance during expansion of the EB. N is a measure of soil stiffness and soil strength. The grouting record is obtained for each pile and offers in this way a unique method of quality documentation. EB plus FDP. An important improvement of the auger pile method was the introduction of a specially designed displacement auger, the full displacement auger pile, FDP, with a specially designed drilling tool, which during penetration displaces the soil laterally. Another important advantage of the FDP method compared to conventional bored and auger piles is that the installation process can be monitored and documented in great detail. Different parameters can be recorded during pile installation, such as crowd, torque, probe penetration, extraction speed, grout or concrete volume and pressure. These parameters provide valuable information to the machine operator, who can adjust the installation and pile construction process to the prevailing soil conditions. Also, interpretation of the measured parameters provides valuable information regarding the soil conditions along the pile shaft during installation. In many ways, the FDP system is an ideal complement to the EB pile system. Combination of the EB with the FDP results in an efficient foundation solution, especially in loose and medium-dense soils. Case history. In April 2013, 4 strain gauge instrumented piles, 2 bored piles and 2 FDP piles were constructed and subjected to static loading tests with the objective of comparing the load movement response and the load distributions for the piles. One of each pile type was equipped with an expander base, EB, at the pile toe. The piles were statically and dynamically tested. The load distribution was measured for each step of load, and the comparison of resistance, due to the pile installation system, was clearly noticed. The FDP pile showed a unit friction resistance more than 3 times than the conventional bored piles. The toe resistance was greatly enhanced thanks to the use of the EB. General conclusions. More than 11,000 expander bodies were installed in Santa Cruz, Bolivia. The main advantage of the EB is the compaction that is produced in the surrounding soil, plus the increment of the toe area. An important feature of the EB system is the ability to monitor the EB expansion process. EB installation in combination with the full displacement shaft, EB, plus FDP, further increases pile shaft capacity. Recent field tests demonstrate that the pile capacity can be increased at least 4 times, compared to conventional bored piles. In summary, the EB system is beneficial in quality and security, electronically monitored control system, soil compaction because of the post-grouting, less time, decreases execution deadlines, works by using fewer piles. Cost reduction, costs reduced per ton resisted. Flexibility, can be combined with conventional pile systems, and/or installed in difficult conditions. Expander body, is the only deep foundation system, which provides information about the behavior of the pile toe. Expander body. High-tech foundations.